Have you ever wondered if the universe is keeping one final secret from us? For more than a century, astronomers have believed they understood the universe's overall design. On the largest scales, everything should be evenly distributed. Galaxies can spin in different directions, but when viewed across billions of light years, those rotations should balance out. The cosmos shouldn't favor one direction over another. That idea has been one of the foundations of modern cosmology. But what if it isn't true? What if the James Webb Space Telescope has uncovered evidence that the universe isn't as symmetrical as we once believed? Instead of answering old questions, Webb may have opened the door to an entirely new mystery. Since its launch, the James Webb Space Telescope has changed astronomy in ways few imagined. Its powerful infrared instruments allow scientists to look farther into space, and farther back in time, than any previous observatory. Every distant galaxy it photographs is like a time capsule, showing us what the universe looked like billions of years ago. And almost every time Webb peers into the deep cosmos, it reveals something unexpected. It has discovered galaxies that appear surprisingly mature for such an early period in cosmic history. It has detected hidden populations of small asteroids in our own solar system, helping scientists better understand potential impact hazards. It has also transformed our knowledge of distant planetary systems, revealing that many rocky worlds are far more active and complex than researchers expected. Each discovery reminds us of the same lesson. The universe is rarely as simple as our theories predict. Recently, astronomers studying hundreds of distant galaxies noticed something that immediately caught their attention. These ancient galaxies weren't just scattered randomly across space. Many of them appeared to rotate in the same preferred direction. At first glance, that might not sound extraordinary. After all, every galaxy spins. But according to the standard model of cosmology, there should be no overall preference. Some galaxies should rotate clockwise, others counterclockwise, and over a large enough sample, both directions should appear in nearly equal numbers. Instead, the observations hinted at a small but intriguing imbalance. Could it simply be coincidence? Possibly. Could it be caused by limitations in the telescope or the way the data was analyzed? That's another possibility scientists are actively investigating. Astronomy has seen apparent patterns disappear before as larger datasets became available. For that reason, researchers are being extremely careful not to draw conclusions too quickly. Yet the mystery refuses to disappear. Interestingly, Webb wasn't the first telescope to hint at this phenomenon. Earlier sky surveys had reported similar patterns, although the evidence remained controversial. Now, with Webb's sharper vision reaching farther into the ancient universe, those earlier observations are receiving fresh attention. If future studies confirm the same trend, the implications could be enormous. Because a preferred direction would suggest that something influenced the universe on the largest possible scale. It would challenge one of the basic assumptions that has guided cosmology for decades. Scientists call this assumption isotropy, the idea that the universe looks essentially the same in every direction when viewed on sufficiently large scales. If that assumption turns out to be incomplete, then our understanding of the universe's birth may also need to change. What could cause galaxies separated by billions of light years to share a common orientation? Could some unknown physical process have shaped the early universe? Or could the answer lie even deeper, in the very moment the universe came into existence? Some theoretical physicists have proposed an astonishing possibility. What if our universe inherited motion from an earlier cosmic event? It's an idea that sounds like science fiction, yet it has been explored in serious scientific research for years. The evidence is nowhere near conclusive, and many alternative explanations remain on the table. But if the strange pattern seen in these distant galaxies proves to be real, It could point toward one of the boldest theories ever suggested. A theory that asks an almost unbelievable question. What if the Big Bang was not the true beginning? What if our entire universe emerged from the interior of something far larger? And that remarkable possibility is exactly where our story continues. For most of us, a black hole represents the end of the story. It's a place where gravity becomes so powerful that nothing, not even light, can escape once it crosses the event horizon. Matter falls inward, space and time become distorted, and according to classical physics, everything is crushed into an infinitely small point called a singularity. But many physicists believe nature may never allow true infinities to exist. Instead, they suspect that our current theories simply break down under such extreme conditions. This is where one of the most fascinating ideas in modern physics begins. Several theoretical models suggest that quantum effects could prevent matter from collapsing into an infinitely dense singularity. Rather than ending in complete destruction, the collapsing material might reach an incredibly dense state before expanding again under entirely different physical conditions. If that happened, a black hole wouldn't necessarily be the end of everything. It could become the beginning of something new. Some researchers have proposed that every black hole might contain the seeds of a completely new universe. From the outside, an observer would see matter disappearing beyond the event horizon. But inside, an entirely different history could unfold. Time would no longer behave the way it does in our everyday experience. A region that appears frozen from the outside might experience billions of years of cosmic evolution within. In that newborn universe, galaxies could form, stars could ignite, and planets could eventually appear. To any observers living inside that expanding cosmos, it would look remarkably similar to what we call the Big Bang. This idea remains highly speculative, and there is currently no direct evidence proving it is correct. However, it offers an intriguing way to think about one of the biggest unanswered questions in science. What existed before the Big Bang? If our universe emerged from a collapsing black hole, then the Big Bang would not represent creation from absolute nothingness. Instead, it would mark the beginning of a new chapter in a much larger cosmic cycle. Now consider another possibility. Black holes are not always motionless. Many of them spin at extraordinary speeds. If a rotating black hole gave rise to a new universe, could some of that rotation be passed on? Not as giant spinning stars or swirling planets, but as a subtle preference embedded into the large-scale structure of space itself. This is one reason why recent studies of galaxy rotation have attracted so much scientific interest. If future observations continue to show that ancient galaxies share a preferred rotational direction, physicists will need to explain why. Perhaps the answer lies in unknown processes during the universe's earliest moments. Perhaps it points toward new laws of physics that have yet to be discovered. Or perhaps it is simply the result of hidden observational effects that will disappear as more data becomes available. Right now, no one knows. And that's exactly how science is supposed to work. Extraordinary ideas must survive repeated testing before they become accepted. Astronomers will continue observing millions more galaxies with James Webb and future telescopes. Independent teams will analyze the data using different methods, searching for any sign that the apparent pattern is either real or simply a statistical illusion. Only after years of careful investigation will scientists know whether this mystery changes our understanding of the universe, or quietly fades away. Regardless of the outcome, James Webb has already achieved something remarkable. It has pushed humanity's vision farther into the past than ever before. With every new observation, it reminds us that the universe still holds countless mysteries waiting to be explored. Perhaps these strange galaxy rotations will eventually have a simple explanation. Or perhaps they will become one of the first clues that our cosmic history is far more complex than we ever imagined. For now, the evidence remains incomplete. But every image captured by James Webb carries light that has traveled across billions of years, bringing with it pieces of a story that scientists are only beginning to understand. Maybe the greatest discovery isn't that we have found all the answers. Maybe it's that we have finally learned how many questions remain. And somewhere in that ancient light may lie the clue that reveals not only how our universe began, but whether its story truly started there at all.